When the Indian Air Force surpassed China in global rankings, was this a true reflection of strength or a carefully orchestrated numerical illusion? Recently, the World Modern Military Aircraft Directory, a U.S. think tank, released its global Air Force rankings, placing the Indian Air Force third worldwide, with the Chinese Air Force relegated to fourth. This outcome sparked jubilation across India. However, closer scrutiny casts doubt on the credibility of this ranking, which appears more like a carefully orchestrated geopolitical drama than an objective assessment of military strength. This controversial ranking employs an evaluation system called TrueVal, which claims to comprehensively consider multidimensional indicators such as modernization levels, logistical support, and offensive and defensive capabilities. According to this system, the Indian Air Force scored 69.4 points, while the Chinese Air Force scored only 63.8 points. On the surface, India appears to hold a slight edge, yet the reality behind these numbers is far more complex. Notably, this ranking emerged immediately after India finalized a series of military cooperation agreements with the United States, including a $3 billion letter of intent to purchase F-15X fighter jets. This timing inevitably raises questions about the geopolitical motivations behind the ranking. Indian media celebrated the ranking with enthusiasm, eagerly advancing two distinctive arguments to justify their superiority. First, they claimed India's Air Force possesses a more balanced and robust fleet composition than China's. Indian media triumphantly pointed out that only 31.6% of the Indian Air Force consists of fighters, 29% are helicopters, and 21.8% are trainers, whereas the Chinese Air Force has a fighter ratio as high as 52.9%. This argument is laughable. The Indian Air Force isn't unwilling to acquire more fighters. It simply lacks the capacity to obtain sufficient numbers of advanced aircraft. In reality, the IAF itself acknowledges needing at least 42 fighter squadrons, but currently operates only 31, leaving a gap of 11 squadrons. Its indigenous Tejas light fighter program, launched in 1983, has delivered an average of just 2-3 aircraft annually after 40 years of development, far short of requirements. This so-called balance actually exposes the severe deficiencies in India's aerospace industrial base. Second, Indian media frequently touts the Indian Air Force's multinational equipment portfolio as evidence of diversity and resilience in its supply chain. Indeed, the IAF operates a seemingly diverse array of aircraft, including Russia's Su-30 Mki and MiG-29, France's Rafale and Mirage 2000, and America's C-17 transport aircraft, and CH-47 helicopters. However, this diversity does not translate into enhanced combat effectiveness, but rather creates a logistical nightmare. Serious compatibility issues exist between equipment from different nations, making training, maintenance, and ammunition supply immense challenges. Take the Su-30 Mki, the backbone of the Indian Air Force, as an example. Its operational readiness rate has long hovered around 55%, far below the international standard of 70–80%. Ironically, the Zukhmi radars installed on India's Russian-imported MiG-29K carrier-based fighters malfunction after just dozens of operational hours on average. The same problematic radar is also fitted to the MiG-29 UPG fighters operated by the Indian Air Force. In contrast, the Chinese Air Force's domestically produced equipment-centric system, though deemed insufficiently diverse by Indian media, ensures the integrity and autonomy of its equipment ecosystem. Currently, the PLAF has established a new generation combat system centered on the J-20, J-16, and J-10C fighters, with supporting aircraft like the KJ-500 early warning aircraft and Y-20 transport aircraft also fully domestically produced. Following Indian media logic, wouldn't the U.S. Air Force, whose main combat aircraft are almost entirely domestically produced, be considered less healthy than the Indian Air Force? The gap between the two nations becomes even more pronounced when comparing equipment generations. The Chinese Air Force has already deployed two fifth-generation fighters, the J-20 and J-35, with the J-20 fleet estimated to exceed 200 aircraft. It is also actively advancing the development of sixth-generation fighters. In contrast, the Indian Air Force currently possesses no fifth-generation fighters. Its indigenous AMCA fifth-generation fighter program remains in development, with no clear timeline for formal deployment. India had previously planned to procure U.S. F-35s but abandoned the effort due to political and technical obstacles, instead considering additional Rafale fighters as a transitional solution. China also holds a clear lead in key support assets such as early warning aircraft and aerial, refueling tankers. The digital array radar technology employed by the KJ-500 early warning aircraft represents a full generation ahead of India's current Falcon early warning aircraft. Meanwhile, the deployment of the Y-20 heavy transport aircraft has enabled a qualitative leap in China's strategic airlift capabilities. The gap in combat effectiveness was starkly exposed during this year's India-Pakistan aerial clash. In the May 7th engagement, a Pakistani Air Force J-10C fighter launched a PL-15E long-range air-to-air missile from 181 kilometers away, precisely downing an Indian Rafale fighter. This real-world example utterly shattered the myth of the Indian Air Force's superiority. Indian media's explanation was laughable. They claimed the issue wasn't the Rafale's performance, but intelligence failure. They were unaware the Chinese PL-15E missile's actual range far exceeded the officially stated 145 kilometers. Such excuses amount to an admission of China's missile technology advancement and the success of its secrecy efforts. The PL-15E's combat performance is indeed astonishing. Its dual-pulse solid-fuel rocket motor and active, phased array radar seeker enable it to ignite twice during high-speed flight while maintaining stable tracking under intense electromagnetic interference. Currently, only China and the United States possess this technology. Russia's R-77M and Europe's Meteor missiles have failed to achieve comparable capabilities. More dramatically, the wreckage of the downed Rafale also revealed an unexploded Meteor missile. This top-tier European weapon proved utterly helpless against the PL-15E. Data indicates that while the Meteor boasts a nominal maximum range of 150 kilometers, its guidance accuracy during the unpowered glide phase deteriorates sharply, resulting in an effective range of only 60% of its stated value. China's defense industry strategy of understatement was vividly demonstrated in this aerial combat. The 145 km range disclosed at the Zhuhai Air Show corresponds to the minimum energy range, a deliberately conservative figure. In actual combat, when launched by a J-10CE at Mach 1.5 and 10,000 meters altitude using a high arcing trajectory, the missile's range can exceed 200 kilometers. This discrepancy between paper specifications and real-world performance fundamentally aims to prevent adversaries from exploiting technical parameters for targeted countermeasures, while also reflecting the Chinese defense industry's robust confidence in its technological capabilities. In contrast, Indian weaponry often suffers from inflated performance claims. Its Astra missile, under development for 2 decades, still lacks full operational capability. The gap between the two nations' aviation industrial systems is even more profound. China has established a comprehensive aviation R&D and manufacturing ecosystem, forming a self-reliant and controllable industrial chain spanning fighter jets, transport aircraft, engines, and avionics. The WS-10 series engines have entered mass production, and the more advanced WS-15 has completed development. India's aviation industry, however, has yet to overcome the technical bottleneck in fighter jet engine development. The Tejas fighter still relies on the American General Electric F404 engine, while the indigenous Kaveri engine project, after over 30 years, was ultimately scrapped. Such gaps in core technology cannot be bridged by purchasing foreign equipment. Looking back at this controversial ranking, its underlying motives are questionable. Some analysts point out that the TV or index method is essentially a cheating tactic, reaching a conclusion first, then seeking evidence to support it. If evidence is insufficient, data is manipulated to ensure India surpasses China. American media are not unaware of the actual situation. They deliberately hype India to achieve undisclosed objectives, attempting to position India as a frontline force against China. Even some Indian media outlets expressed surprise at this ranking, acknowledging that the Chinese Air Force far surpasses India in both technical capability and overall strength. Chinese military expert Zhang Junsh commented that military rankings should be based on real capabilities rather than paper statistics, noting that such hype benefits no one. Indeed, from the total number of combat aircraft to the aviation industrial system, from independent R&D capabilities to the integrity of its equipment systems, the Chinese Air Force possesses comprehensive advantages that India cannot match. The Indian Air Force faces not only aging equipment and delays in indigenous projects but also systemic gaps across its entire defense industrial base. So while India's Brit gentlemen cheer this ranking, we might offer a knowing smile. After all, on the real battlefield, there are no illusions of rankings, only the clash of truths.